Hello Cloud Gurus, and in this section I'm going to introduce the DynamoDB consistency model. It's a fairly important concept to grasp both from a performance and a cost perspective, and in the following slides I'll talk you through how it works and what impact it can have on your applications. A good place to start is to introduce some core concepts of DynamoDB. Firstly, DynamoDB utilizes highly reliable and resilient SSD storage across the entire product. It does this in order to achieve a consistently reliable and low latency set of operations for reads and writes across the entire product. Later in this course, I'll illustrate why latency is essential in managing performance, but for now, just know that it's a design aim of DynamoDB. Now, I mentioned in the DynamoDB fundamentals lesson that DynamoDB is, by design, a highly tolerant and highly available platform, but I didn't give too many details as to how this is accomplished. In the back end, for every piece of data managed by the platform, DynamoDB replicates this data to 3 geographically separate locations. AWS could have critical disasters at 2 separate locations, and your data would still be safely held at the 3rd. The key to DynamoDB's consistency model is based on how this process occurs in the background. Let's step through this so we understand it. So let's say you, as an application developer, are interacting with DynamoDB, and in doing so, you decide to update an item in a database table. What you see as a client is a 2-step process. First, you write your data to the table, and you do this via an API connection to the DynamoDB endpoint. And this is done even if you're using the DynamoDB console. Assuming all is well, you receive a response back indicating that your write was successful. Now, what actually happens in the background is not quite as simple as this. I've already mentioned that DynamoDB needs to store that data 3 times to meet its defined service level. It's very possible that a HTTP 200 response, which indicates a successful commit, will be returned when only 2 of the 3 data replicas have acknowledged the write. In the background, DynamoDB then ensures that the 3rd data replica silently receives the update in the background, and full consistency is then achieved. And this generally happens in less than a second, even under substantial transactional load. Now, this may be important because if you are used to or trained in the world of relational databases, you will be used to a model where consistency is prioritized above performance, and where a data read will always return a result which matches an update made by a recent write. With DynamoDB, this isn't always the case, and it's a critical point to understand as it allows you to design effective application or DB implementations. Now let's look at this closer. Let's assume the write we discussed a second ago has occurred. Data has been written to and acknowledged by DynamoDB with a 200 response. The system is highly transactional, and in that same instant, or 100 to 200 milliseconds later, another application component, say a mobile device running in another part of the world, makes a data request for the item that was just updated. What version of the item would the mobile device receive? The 2 copies which contain the updated version, or the older version? The simple answer, without any specific configuration or deviation from defaults, is it depends. It could get the old version, or it could get the new version, and this is what's known as eventual consistency. Now let's move on to the next slide, and I'll step you through more details around this scenario. This is a subset of a HR table for a large organization. Let's assume that Jill marries John and goes for the traditional option of taking John's surname. Jill Smith now becomes Jill Matthews. As part of this process, a request is lodged with HR, and HR run an operation to update the staff table. DynamoDB accepts the data update and acknowledges the write. And in the background, 2 of the 3 data replicas are updated. And then a very unfortunately timed payroll batch process occurs, where every item in the staff table is read, runs some processing, generates some payslips, and the payslips are printed. Now remember, DynamoDB is by default eventually consistent, and it preferences performance over consistency. So we have two possible outcomes regarding the payroll process. The first is that the read operation runs in its default eventually consistent mode. It consults the most available storage location, and it's the one which hasn't been updated. DynamoDB returns the old data, and one more tree has to die when Jill's payslip has to be reprinted, which is not ideal. The second possibility follows the same logic as above, but this time the randomly chosen replica is the one which contains the new version of the data. The data is read, Jill is happy, and we don't have to print another payslip, which saves part of an Amazonian rainforest. Now this is something that as a DB operator or developer you need to be aware of. In certain use cases, eventual consistency is perfectly fine, such as a high score table for a game or a dashboard showing cumulative non-live data in an office setting. These applications can cope with a margin of error in data consistency, but certain mission-critical applications cannot. And this is where option 3 comes in. We can issue a read request to DynamoDB, but instruct it to perform a strongly consistent read. In this case, DynamoDB checks all replicas, and the one with the most recent version of that item or attribute is returned to the requester. So why not always use strongly consistent reads? Well, we could, that's an option, but it's more expensive from a resourcing perspective to do so. With strongly consistent reads, each read needs to check multiple data locations. In effect, it performs at least 2 reads for each block of data you want, and so DynamoDB charges extra for strongly consistent reads. And to be 100% accurate, it actually charges less for eventually consistent reads. While eventually consistent reads are the defaults, all costing and performance settings assume that you want strongly consistent operations. So while the default is eventual consistency, whenever you're setting performance on a table, you're setting it assuming strongly consistent reads. And by doing so, it means you can get twice as many eventually consistent reads. So key takeaways for this lesson is to understand that your data is replicated to 3 locations, and know that whenever any data writes happen, that you're writing that data to all 3 locations, but there is a chance that you'll receive a commit OK message after only 2 of those replicas have been updated. And there is a small chance that a read immediately after a write will retrieve out-of-date information from the non-updated replica, unless you specify that you want a strongly consistent read. And a strongly consistent read will read from multiple locations at the same time to ensure it retrieves the most up-to-date copy of the data. And if you remember the database fundamentals lesson where we talked about ACID, one of the elements was the consistency aspect of relational databases. Now, DynamoDB sacrifices consistency in order to achieve performance, and a configurable element of this is whether any reads that you request from DynamoDB are eventually consistent or strongly consistent. So remember, as a database administrator, you have complete control regarding data read consistency, and that is an incredibly important thing to remember for the remainder of this course. When specifying performance, you're specifying performance based on strongly consistent reads, but eventually consistent reads are the default for any read operations in DynamoDB, and eventually consistent reads are half the cost of strongly consistent reads. Well, that's the end of this lesson, Cloud Gurus. If you have any questions about any of the subjects covered in this lesson or others, feel free to reach out directly or via the Cloud Guru forums. Otherwise, thanks for listening. Feel free to complete this lesson and move on to the next.